I think we'll get started. Good morning, everybody. Good afternoon. My name is John Holland. I'm the Chief Development Officer for Pinchin, based in Richmond, BC. Welcome to our Practice Innovation webinar on asset retirement obligations for public entities. I'll be a moderator today and look forward to an interesting presentation. In April 2022, all public sector organizations are required to report their retirement obligations for all tangible assets, including anything acquired, constructed, or developed by the organization, and have their costs calculated and accounted for. Evaluating these costs may require a much more specific level of accounting and rigor and building and assessment. Buildings, contaminated sites, utilities, solid waste landfills will all have to be decommissioned at some point, and we hope this webinar will help you evaluate that process and make your job easier. We have, I'll just do a quick summary of the webinar process. Get comfortable, just check your volume, maybe raise your hand to make sure we can be heard. There is a chat function if you have technical issues accessing the webinar, and we have Q&A for any questions you have. And there'll be no polling, but there will be a questionnaire at the end. Let's have the next slide, please. So we have 4 very good speakers with you today, including a guest speaker, Marcus Gonsi of BDO Canada, who's kindly agreed to set the framework for this new area of endeavour. Marcus is the partner of BDO Oakville with over 20 years experience, largely with public sector clients, with whom he does presentations regularly. And he has a wealth of experience at this level of reporting. In lieu of a fee for today's presentation, as an external presenter, Marcus has kindly offered to make a presentation on behalf of a charity of his choice. So thank you, Marcus, for that. Sean Douglas is our second presenter. He's our national practice leader of hazardous materials based in Richmond, BC, and has over 35 years experience working in the hazardous materials area, assessment and remediation all across Canada. And our third speaker is Mr. Dale Weeb, who is a branch manager in Northwest Ontario and a practice specialist in wastewater and potable water. He's based in Kenora and has over 20 years experience in just about all the practices we do, but specializing in contaminated sites, wastewater and drinking water management. And the final speaker is Mr. Tim McBride, who is based in Northern Ontario in Sudbury. He's our operations manager of Northern Ontario, and he's also a practice specialist in hydrogeology. He's over 30 years experience practicing heavily in the contaminated sites, hydrogeology, and landfill management area. So thank you to all the presenters. And with that, I'd like to pass the presentation over to Marcus to start our presentation off.
Okay, thank you very much, John. So what I'm going to do is I'm going to start off by setting the stage for the asset retirement obligation standard and walking through some of the technical elements of the standard so that everybody is familiar with it. If we could please advance to the next slide. So what is the asset retirement obligation standard? First of all, the effective date is important to note. It was effective for year ends beginning on or after April 1, 2022. So that means March 31st, 2023 and subsequent year ends is what this standard applies to. Now, I know that not everybody has adopted this yet, despite the fact that it was required to be adopted. And that is because the complexities and the cost of adopting this standard are quite significant. And as a result, some organizations just haven't been able to find the capacity to do so yet. So for those of you that haven't yet adopted, we'll go through some of the first-time adoption and scoping elements of adopting this standard. For those of you on the call that have already adopted the standard, I'll speak to some of the subsequent measurement issues and what you need to be wary of for future reporting periods after adoption, which would be where you're at today. So in terms of framing an asset retirement obligation, what is an ARO? It is a legal obligation associated with the retirement of a TCA. And a legal obligation can take many different forms. It could be an agreement or contract. It could be a promissory estoppel, or it could be the most common type that we see, which is government legislation, i.e. an environmental standard. If you do have an ARO, how do you account for that in your financial statements? So first, you would increase the amount of the tangible capital asset by your ARO amount, and you would record a corresponding asset retirement obligation liability. If the TCA is no longer in use, you would expense your ARO as a period cost. And if it is still in use, but it is fully depreciated, you have the option to do either of those alternatives. A present value technique is often the best method to estimate your ARO. It is certainly what I would recommend. The way the standard is written, however, doesn't mandate that, it suggests it. So as a result, we have seen a number of our clients that have used a present value technique, but others that have chosen not to. That is a matter of preference, but again, my recommendation would be to use a PV technique. And finally, just to avoid confusion between a similar standard PS 3260, which is liability for contaminated sites, the difference between 3260 and 3280 is simply that 3260 applies when you've already exceeded an environmental standard, i.e. you have active environmental contamination, such as a fuel or oil leak, for example, or something in the groundwater like that, as opposed to ARO could be completely contained. One of the biggest examples we see across our clients is asbestos in older buildings. And if that asbestos is completely contained, i.e. not exposed to the environment, it is still within the scope of PS 3280, and an asset retirement obligation is required to be estimated and recorded. Next slide, please. So some of the audit implications, for those of you who have not yet implemented the standard, what do you need to consider in your year of implementation? The most important part by far from an auditor's perspective is the scoping or identification phase. It is ensuring that you have identified all of the ARO your organization has. That's not the full battle. There's a lot that goes into the work once you've figured out what you have. But figuring out what's there is extremely important from an auditor's perspective. And in order to do so, you're going to need to involve different people within your organization. Unlike most auditing or accounting standards, this is not something that the finance team can unilaterally work through. You will need to include people from your legal, your operations, your facilities teams, just to make sure that you have a fulsome understanding of where your ARO might be. You can also, as a starting point, use your fixed asset listing, your lease listings, or if you have capital and strategic plans, you can certainly look at those and they might give some light into where your ARO are. Once you have identified those ARO, it is important to use external consultants. I think it's safe to say that none of us, whether it's an auditor or an internal finance team, have the expertise to estimate the amount of a retirement obligation. So that's where you bring in people like Pinchin to help you estimate the amount of future remediation costs related to any ARO that you might have. And then finally, consulting your auditor throughout the process is extremely important, given the complexities of this standard and the length of time it will take you for a scoping phase. It is important to keep your auditor abreast of what is happening throughout. So once you have adopted this standard, what do you have to consider from a subsequent measurement perspective? So the standard actually mandates that you must revisit all assumptions at each reporting period. And that is very important. This is not just a set it and forget it standard where you estimate your costs in the year of adoption and then you write it out through an amortization table, just recording standard entries every year. You are required to step back and look at your discount and inflation rates, your estimated time to abatement and potential early retirement, and to adjust your ARO to consider those items. Additionally, cost to remediate. It's on its own bullet point there because it's extremely important. Again, you don't just get that cost estimate in year one and then assume no changes for the next 10 or 20 years until your estimated remediation date. You will have to update the cost to remediate in a somewhat frequent time frame. There's no rule of thumb for that. It's a matter of professional judgment, but it is something you do have to consider at each subsequent reporting period. Those that choose to use the present value technique that I referred to previously will have an annual accretion expense to record each year. And then finally, you need to consider changes due to errors. You may note errors throughout your process. For example, perhaps you missed an ARO in your year of implementation that you catch 1 or 2 years down the road, that would be an error. So that would not be a period cost. And to the extent that that is material, you may have to consider recording a prior period adjustment to reflect that properly within your financial statements. So that's it from my perspective. I'm now going to pass it off to Sean, and he's going to go through some of the hazardous materials.
Well, good morning and good afternoon, everyone. So our first technical topic today regarding asset retirement is hazardous materials. So when it comes to hazardous materials and how it relates to asset retirement, the removal of hazardous materials normally results in significant liability and cost. There is legislative requirements that stipulate under law that hazardous materials must be remediated prior to building demolition or disposal. And these legislative requirements fall under health and safety regulations, whether they're provincial or federal. They fall under the hazardous waste regulations, which is typically a provincial regulation in each province of Canada. And there's also federal regulations concerning PCBs. So these are all the different types of hazardous materials that could be affected by building demolition, whether it's asbestos, lead paint, or PCBs. These need to be remediated properly and correctly prior to building demolition, and it's reportable under asset retirement obligations. So when it comes to asbestos is particularly named in the PS 3280. And asbestos is one of those things that was added to very many different types of building materials throughout the 20th century because it added a lot of unique properties to materials. It enhanced fire protection ratings, it enhanced insulation, heat loss, and it had a very high tensile strength. But what happened is that when the health effects of asbestos became publicly known, particularly in about the mid-1970s, asbestos use was lessened and curtailed. And many asbestos products were phased out, certainly by, starting in the 70s, throughout the 80s, and into the 90s. There is limited use of asbestos even after 1990. You might be surprised to hear that asbestos was actually not formally banned in Canada until 2018 under the prohibition of asbestos in products containing asbestos regulation. So there's lots of different types of materials that could be within your tangible capital assets, particularly the buildings in question. And these range from materials like fireproofing, which is applied to concrete and steel to enhance fire protection ratings. It could be, asbestos could be added to pipe insulation or boiler insulation to reduce heat loss. It was added as a strengthening material to different types of surfacing and compounds, whether it's drywall joint compound, texture coats, stipple coats. Asbestos was added to these materials for strengthening and durability. And it was also used in some of the cement rainwater leaders, which are used for transporting water from roofs down to the drains, or also in sanitary drains. It was also used in different types of finishing products, like floor tiles, flooring, vinyl floor tiles, various sizes and shapes and colors. It was added as a fire retardant to ceiling tiles, whether it's even the lay-in tiles, which is a 2x4 lay-in tile, or even the 12x12 tiles. Asbestos was sometimes added as a fire retardant. Asbestos was also within vermiculite, and vermiculite is one of those unique items where it was added into attic spaces and block walls for thermal insulation, but the asbestos actually wasn't put there for any particular reason. It was really a contamination during the mining process when it was mined in Libby, Montana. So there is a lot of different types of materials that can contain asbestos. And when we do our investigations for the assessments, these are the materials that we're looking for. You'll see that I've highlighted some of the items in green, which are what's known as friable materials. These materials tend to be more expensive to remediate because they release asbestos more readily when disturbed. And then the yellow ones are what's known as non-friable materials, which are things that don't break down very easily upon handling. But there's quite a lot of different types of non-friable products that could be asbestos. Everything from roofing to sealants to caulkings to putties, vibration dampers, thread sealants. There's over 3,000 documented products that contain asbestos in the formulation. So, as I mentioned earlier, that asbestos was curtailed starting in about 1970s. And I just wanted to throw this slide here just to sort of illustrate how it became less prevalent. And it really started in the 70s in the United States under the US EPA banning certain types of materials. And then it sort of followed through to Canada in sort of regional prohibitions around applying asbestos products, whether it's in British Columbia or Ontario. And then there was sort of regional or localized bans on products. For example, durable joint compound was banned in 1980 in Canada. And then there was certain prohibitions around spray applied products, even up until 1989 under the Hazardous Product Act. And then that vermiculite mine in Montana, that closed in 1990. And then finally the prohibition in 2018. And the one thing I just wanted to add to this is that non-friable asbestos, so that list I had up earlier with the different types of caulkings and mastics, really wasn't banned at all until 2018. And we are seeing evidence of those types of materials in buildings. So to complicate things, or I guess to help unravel this, when we say that asbestos was used in different products, what we did at Pinchin actually to help us when we're calculating our costs and working out what to sample for and coming up with your list of TCAs, we actually did an internal study at Pinchin where we analyzed 300,000 different samples in order to predict the type of asbestos as relating to the data construction. And you'll see here in the top right in the graph there, the table, the bar chart, sorry, that we actually sample all these different types of materials and broke it out into sort of dates of construction. And what we concluded is that friable asbestos really stopped being used in 1986, which supports the previous bans that I had mentioned. But what we found out is that non-friable asbestos was used up until at least 2010, past this sort of 1990 date that seems to get used quite a lot in reference material. Certain things like cement pipe, vinyl floor tile, mastics, adhesives, tars, caulking, and gaskets. And what this does is it allows us to target these materials based off dates of construction when we're doing our investigations to calculate asset retirement costs. So not only is there asbestos that we need to deal with, there's other types of hazardous materials, things like lead paint. Lead paint was very common. It was unrestricted in use. In other words, you could put as much lead as you wanted to up until 1978. And then it slowly got restricted as the years went on. And the current standard is 90 parts per million based off of 2010 regulations. The other type of hazardous material you might encounter in buildings is PCBs. PCBs are used in dielectric fluids and transformers and electrical equipment, capacitors and ballasts. The production of PCBs stopped in 1978, and there is allowance to be using PCBs, certain types of materials, particularly ballasts and pull-top transformers up until the end of 2025. So that if it's in use, you're actually still allowed to keep that in use up until the end of this year. You might be surprised to know that PCBs was also used in non-liquid forms. in other words, plasticizers. We have experience finding PCBs in caulking and exterior paints, which does add additional handling costs. And then, finally, mercury in control switches and gauges, thermostats, and fluorescent light tubes. That also needs to be considered in the asset retirement calculations. Okay, so let's talk a little about sort of the process of how to estimate the costs. So I've broken it down into sort of four steps here. The first step is to scope, project scoping. And this is where you're going to review the list of tangible capital assets, or TCAs, and this is in conjunction with yourself and your consultant and your auditor and your team, and look at what is there, and then review sort of when was built, what are the sizes of the buildings, any type of configuration, and try and group it into various groups, and set an expectation of what to look for under your asset retirement obligations. Are we doing a deep dive into all of them? Are we doing a more cursory investigation? We need to set that expectation right up front. And then if there's any historical reports on file, that would be helpful to review, and then identify any gaps that may affect the outcome. The second step in the process is to conduct an assessment. And this is where you would do a detailed investigation of the site, methodical sampling. So in other words, your consultant now is going out into the field, collecting samples, measuring the quantities of materials that can contain asbestos and lead paint and so forth, conducting laboratory analysis, and then correlating all that data into some type of manageable report. The next step is to calculate the costs. And this is where there's different models. I'm going to go through some examples in a few minutes, but you're going to calculate the costs using either internal rates or other types of known rates that are available. And then also what's important is to consider the regional or local market conditions and use professional judgment and experience where necessary. And then the fourth step is to report. You're going to tabulate the costs. You're going to document the methodology, and it's really critical to document that methodology because you need to state what limitations that may affect the accuracy, so that if you are audited, you can go back and look at exactly how you actually did that calculation. So when it comes to remediation and costing, the remediation, the asbestos portion tends to be the most significant cost. And the reason for that is because all the regulations across Canada have very onerous regulations on how to handle asbestos. So the regulatory framework and the methods for handling asbestos from removal and disposal are highly regulated and enforced. So the costing sort of goes along with that. And I mentioned earlier that the costing for asbestos does vary quite a lot depending on what type of material that you're handling. If it's friable material, it tends to be more expensive to handle than non-friable material. And there also is variation between geographic location on costing, even within regions, certainly by province to province, but even within regions. And I'll give you one example. I live out here in Vancouver, BC, and if you are handling asbestos containing drywall joint compound, you can't actually recycle that. The recyclers won't accept it. And the landfill, the hazardous waste landfill here in Vancouver won't accept it either, because drywall is banned from the landfill. So drywall has to be shipped out of province, and that's generated, asbestos drywall has to be shipped out of province, typically to Alberta, at substantial cost for transportation. So that makes it much more expensive. Market conditions does play a factor, whether it's a remote location or maybe the lack of resourcing through contractors. And then the lead paint and mercury and the other types of materials does add handling costs, but certainly it does add disposal costs because many of those types of materials are hazardous waste. And when it comes to the accuracy of the pricing, that really comes down to the thoroughness of the investigation, how detailed data we have. It comes down to the accuracy of the quantities, making sure that measurements are done correctly. And the experience of the estimator plays a big role, considering all these different factors that as I mentioned above. And then we need to make sure that we're including contingencies to address exclusions or assumptions. And I'm going to go through a couple examples of that in a few minutes. So when it comes to calculating the costs, what we do here at Pinchin is that we use unit rate tables, which are based on our experience of running projects, analyzing bids, and comparing it to the actual costs. And then we sort of tabulate it based off of a material type. So you'll see, sort of looking from left to right, the headers there. The column A is the material type, whether it's vinyl floor tiles or plaster or something else. And then we would enter the quantities, and then we calculate the weight of that material as well, because the weight is important to do with disposal costs. And then we would apply unit rates to calculate the labor and materials to handle and remove that material. We do have some minimum costs just for the fact that there is a minimum to deal with these type of materials. And then we sort of subtotal it out when it comes to abatement and disposal. And then abatement costs. And then we add in the transportation and disposal to come up with a total cost. And this is what we recommend the best way to calculate the asset retirement obligations. So there is other ways, and I'm going to run through a couple examples, but there is other ways of doing this. And this is one of the methods that is what's known as the simplified modeling method. And this is where the asbestos inventory or the inventory of hazardous materials is either unknown or very limited. And what this model allows you to do is to just group the buildings into similar size, use, and dates of construction, and apply a unit rate on a per square meter of gross building area to calculate your asset retirement estimates. And there's a couple of examples that are published. There's one which is under the Ontario Ministry of Health. It's called Model 2, where it uses a number of a per square meter based off of the type of building and when it was built and what it's used for. And it does vary quite a lot. And then there's also another example that I'm familiar with in the province of BC under the Ministry of Health. They've allowed a sort of a number on a per square meter just to apply to the gross building area. Now, the problem with these types of modeling methods is that it makes some very wide scoping assumptions. It assumes that everything is the same from one building to another, which is not the case. Some buildings might have different types of asbestos products, some might have none at all. Some may have some materials removed over the years. So there's lots of different variables that are going to play into the accuracy of these methods. So it does create a very high variability of costing because of those reasons. Second method that we would recommend is what we're sort of saying is a better method to do is what's known as the semi-detailed method, or what we call here at Pinchin the semi-detailed method. And this is based off of a report that's on file. There's sort of a term used in the industry called management grade assessments, which means it's a report which has already been filed for the building, which is required under most law anyways for proactively addressing and identifying asbestos and other materials in buildings. And those are quite frequently on file for many different types of assets. but it does have some gaps and exclusions. These reports are typically not used for demolition purposes. It's more used for ongoing operations of the buildings. And there could be a lot of materials that are not tested in those particular reports. Some of those reports might have quantities, they might not have quantities, but nevertheless, we want to try and apply unit rates to the actual quantity of material that exists, and then also apply some type of contingency for anything that is not tested as part of those assessments. A good example could be a roof. Typically, a roofing system would not be cut open to test for asbestos in an occupied operational building because it does create a chance of roof leaks. These type of methods are low to moderate variability. The best method, which we highly recommend, is the detailed method, and that's based off a pre-demolition assessment report. And this is a report which is prepared by a consultant, which tests almost everything possible that we can get access to develop costs. And these are typically done in advance of demolition of buildings, and it's required under law, hence the asset retirement obligation. There's very little gaps and exclusions. So there's destructive testing being conducted, there's roof cuts being tested. We have very detailed information. We have scale drawings in most cases. We have very accurate takeoffs, and we can apply the same unit rates to those materials to come up with costing, which results in a very low contingency. In other words, it's very highly accurate costing, and it's much lower in variability. So just my last two examples here are just showing what that might look like on a tabular form. So this is a table that we did for one of the entities we worked for, which had various types of buildings in their for the city. And what we did is we grouped the building type, the buildings into the various types, whether they're trailers or pump stations, or there was police stations and libraries and so forth. And based off the square footage, there was just a costing per square foot. And again, this is the simplified method, which makes that broad scoping assumptions that all these buildings are exactly the same. We probably could say that a pump station from one part to another part is the same, but when it comes to things like libraries and police stations, maybe not the same. But nevertheless, this is a method which is used when there's very little information available to calculate your asset retirement obligation. And then the last example that I have is the detailed method. And this is where it's based off of a detailed investigation. The report that's on file has tested all the different types of materials. So you'll see here, we have very accurate takeoffs. So if you look at where the orange arrow is pointing towards, these are the confirmed asbestos materials that were identified, and we're applying unit rates based off those quantities that we measured during the investigations to come up with a cost. In this particular example, there was some presumed asbestos-containing materials that weren't tested because this building was actually operational, and that's where the red arrow was pointing towards. Here, what we did is we made some assumptions of these different types of materials that could be within the building based off of our experience and knowledge of the construction of the building and observations, but they actually weren't tested. However, we did apply, based off our experience, a certain positive rate of the different types of materials that could be found, coming up with a costing there. And then we tabulated the lead-containing materials, the mercury-containing materials, the PCBs, and we came up with a final total at the bottom there. And we did add in a contingency in this particular case of 10%. And that is to account for, in our experience, we typically find materials that are unidentified and typically discovered during building demolition. And that's what that contingency is for. And just to wrap up my portion of the presentation, some tips for success is to, number one, compile the list of your TCAs and try and group them into types of building sizes and year built. Create an expectation for the types of asset retirement obligation that you're looking for, whether it's just asbestos or lead paint PCBs. Number three, build the right team. You want to include not only your accounting group, but your facilities group, your environmental health and safety group would have lots of information that they can provide to help calculate these costs, and use those external resources where necessary. So these are the experts, the environmental consultants like ours, and the accounting firms that can help you with this type of information like BDO. And then finally, it's important to document that methodology, assumptions, and limitations, because having that recorded will allow you to go back and check to see what, if anything, needs to be adjusted. And if there's any questions from your auditors, you can look at it and see clearly how that was documented and make any adjustments as necessary for years moving forward. And that concludes my presentation, and going to pass it over to Dale Weeb.
Thank you, Sean. Hello, good morning, good afternoon to everybody. So my portion of the technical talk is going to be to discuss site features and infrastructure. Essentially, those items that are present at properties that make up the TCA list that Sean was talking about, but everything outside of the building hazardous materials and are likely to be present somewhere in your asset list. Next slide. So many of the common site features and infrastructure that could be present in an asset listing, they are governed by regulation. Sean touched on some hazardous materials regulation, but there's a pretty wide variation in regulation that would apply to infrastructure equipment features. And they're basically, the regulation is there to protect the environmental condition of the site, to protect health and safety, or to safely transport and dispose of waste generated at the site as part of the retirement of the asset. It's important to note that many of the regulations that govern this are provincial. So we've got a national audience. We're doing this across the country. So understanding that provincial regulations can and do vary, and can vary quite significantly from one province to the next. It's important to understand the regulatory climate and requirements in the jurisdiction where your assets lie. And if you do have an asset listing that spans multiple provinces, then you should be understanding of the regulations for each individual site. So for project scoping for site features, unlike hazardous materials, asset retirement obligations from site features is independent from age. The age of development, the age of construction, even newly developed properties can have an asset retirement obligation. There could be rural sites that have on-site services such as wells or sewage systems that are governed by provincial regulation, fuel systems and storage, refrigeration and cooling equipment that could range from larger building cooling systems to municipal assets like curling rinks and arenas. And then there could be facility features and equipment which store, use, or produce materials that are regulated. And there's an example of some of those down at the bottom of the page. And all of these are, they're still being installed. These types of features are still being constructed for sites today. Next slide. So I'm going to run through some of the most common site features that we encounter or that could be expected to find. Fuel storage tanks, fuel systems, they're governed by provincial fuel code, and they tend to be very prescriptive at the point of retirement or abandonment of the fuel system. There has to be decommissioning efforts, and the code requirements are generally to purge the contents, disconnect the systems using a licensed fuel handler, to excavate, remove, dispose of the tank itself. Typically, there's some soil and environmental sampling requirement and reporting back to the provincial regulator on environmental condition around the tanks. And then there's a requirement to backfill or restore the excavation site. Again, there's no assumption of contamination, even if it's likely. As an environmental consultant that works with quite a few contaminated sites, you know, a 60-year-old fuel tank in the ground, you know, may have a very significant chance of having some type of impacts, localized or larger impacts around the system, but that would not be captured under PS 3280. It would not be considered an asset retirement obligation. Wells are getting drilled every day for new sites that require on-site service. They are provincially regulated, and the premise for the regulation is to protect groundwater aquifer quality. So the regulation for where a well can be located, the construction and installation details, as well as the fact that once a well is no longer in use, it presents a potential risk to the aquifer quality. So it has to be properly decommissioned. The decommissioning of those wells have to be done by a licensed well driller, and there's requirements to remove equipment and servicing to the well. The well has to be drilled and plugged to prevent a conduit for contaminants to reach the groundwater. And typically there's a correspondence or permitting process with the regulatory authority to remove the registration of the well to show that it's no longer in service. This applies not only to drinking water wells, but also environmental monitoring wells or geothermal wells. On-site sewage systems, also provincially regulated. The regulation regarding on-site sewage systems do vary pretty significantly from province to province. So you certainly are going to want to make sure that you're familiar with the regulation in the jurisdiction that you're looking at. And it would govern the content of the septic tanks and treatment units, the soil quality within the leaching bed, and the evacuation and disposal of hazardous materials and liquids, and the overall decommissioning of infrastructure related to the system. This slide, I've titled it Specialty Systems. They're not necessarily specialty systems, but there's going to be people on this call that have an entire asset listing that don't really encounter any one of these. But as a consultant working in this arena, every other day we are encountering these types of systems that do have a legal obligation. There is a regulation governing them. And so that could be the federally regulated PCBs that Sean talked about, or refrigerants. It could be X-ray or laboratory equipment that has radioactive materials. And then incinerators and lagoons, the final two bullets, generally are provincially regulated, but they're regulated through an environmental approval. And so there would be an application and an approval issued by the provincial regulator on the construction, operation, and ultimately the decommissioning of these features. So the obligation is likely going to be specific to the nature of that equipment. But if any of these features or improvements are within the asset list of your for your organization, then they will have to be looked at for potential ARO. Chemical and waste storage, PS 3280 is specific to materials and equipment and infrastructure that's part of the normal use. So if there is chemical and waste storage that is part of the actual operation or use of the asset, then if there is a regulation governing its transport, handling, disposal, it would be captured as an asset retirement obligation. As you can see by the two pictures, there's kind of a right way and a wrong way to store chemical and waste on site. But you would look specifically at the nature of the chemical or the waste and the regulation governing that and what the obligation would be for its disposal and transport. If there is waste on site that is not part of the normal use, like say historic dumping that may not have been approved or part of the overall use of the site, that would be something that's not captured under ARO, but in fact under 3260 that Marcus discussed at the beginning of the presentation. So an ARO estimate, so typically your estimate is going to be comprehensive. It's going to include any consulting costs, contractor mobilization and labor, the transport and waste disposal of materials that are leaving the site, the permitting or correspondence with the regulator to decommission the asset, and allowing for any contingency. Now, costs should be updated annually. They can be updated for this type of work. If you have an estimate from, to say to decommission a piece of infrastructure and it's from 2022 and you want to be able to understand, well, what am I doing in 2025? Do I have to redo the estimate? Often you can use industry information like the Canadian Construction Index. It's a federal index that's published that tracks construction costs in various regions throughout the country. And it shows like a year-on-year increase within the construction industry. It can be a pretty good resource for calibrating your cost to bring it to today present value. And there are other industry publications out there that you could use along those lines. So having an existing estimate, even if it wasn't done this previous year, certainly there's tools out there that you could use to bring it current. Some considerations, most site infrastructure can be estimated as a desktop exercise. This is a big deviation compared to the hazardous materials that Sean discussed, where the best method is to go on site, because it's the only way to actually quantify and identify the materials that are there. For the site infrastructure, often there's permitting or records, whether it's a well record or a construction permit or an environmental approval. There's information that might be available that details the nature of the infrastructure so that an estimate can be provided. And the more information that's available, the more accurate the estimate's going to be. It's also important to realize what the estimates aren't going to include for project phasing and the cost to accommodate occupants. So if you've got site improvements or features that are part of the operation of the site or servicing for the site, there is no allowance for making multiple phases to the project that involve mobilization and demobilization or accommodating the temporary services, temporary water or wastewater services for the site while systems are getting decommissioned. The pricing is meant to be developed in the most cost-effective and comprehensive ways so that it assumes there is no more occupancy. This is the full decommissioning of the asset, and it's essentially the cheapest way that the project can be done. The ARO budget, though, shouldn't be used in place of proper project estimating when it comes time to decommission that asset, because some of those factors may actually come into play, amongst other things. So if you are looking at budgeting, you've got a retirement that's planned for the next year or the next couple of years, that is where, perhaps a desktop budget is not the most appropriate. You're going to want boots on the ground, do the actual site assessment, verify the conditions on site, verify if there's any phasing or other accommodation that needs to be made so that a proper budget can be developed. Reporting, an ARO report is going to include a description of the asset, a list of information relied upon to develop the estimate, reference to any past report or files reviewed, a list of any assumptions or uncertainty. Sean made a really good point of kind of outlining the different factors of what could impact the uncertainty in the estimate. Certainly understanding where assumptions were made and what impact that has on the accuracy or uncertainty with the estimate is very important. Make sure that expectation is met between the finance team and the auditor. And certainly if that uncertainty is not acceptable, then perhaps more information or assessment needs to be performed to tighten that estimate up. And then a comprehensive estimate provided in present day dollars. So this slide shows essentially the level of detail for a typical grading project for a lagoon closure. There has to be some basis for an estimate to be developed. We need to understand the geometry, the size, the amount of material that might need to be moved. Typically, we would be providing comprehensive unit prices that account for the handling and the transport and the ultimate disposal of that material, and developing a project estimate based upon that. Some more simplified site features may be estimated with a more simple estimate, but in this case, this is an estimate that can be revisited in 2 years, 5 years time, so that you can look and see if there's any site-specific information that has changed, any regional changes to unit pricing that could be made, so that this estimate can be built upon and adjusted and kept current, as opposed to having to be redone at a later date when you need to do additional reporting. So I believe that was my last slide, and I'm happy to turn this over to Tim McBride.
All right, thanks, Dale. Aaron, I'll just let you go to the next slide if you don't mind. So it's been our experience that a number of our clients, landfill operators, landfill owners, often struggle with emphasizing to the powers that be that their waste disposal site is actually an asset. I think you'll notice throughout the presentation today, there's a common theme. Like, all of these issues that we've talked about today are all regulated issues, and waste disposal sites are no different. They're provincially regulated for the most part, and this ARO process has kind of brought waste disposal to the forefront, as far as people realizing that these sites are actually an asset. Historically, unfortunately, by the time you get to the point where you're talking about replacement or expansion of a waste disposal site, an entity is usually in a bad position, given the length and difficulty in the process associated with increasing the capacity or the site life of a waste disposal site. And the reason we talk about site life and capacity is that operations of a waste disposal site have a direct impact on the ARO, as the ARO is often influenced by the site closure and the post-closure requirements. Next slide, please. Most entities that have a waste disposal site know what it costs to operate the facility, but they often fully don't understand the value that it holds. One way to look at it is what it could cost you if you did not have it. So I pulled together some stats here, for what the average Canadian typically produces or generates in tons of waste per year. I got some average numbers for what tipping fees typically are at some municipal landfill sites. So you can see, as you work through these numbers that I presented here, a small community of 3,000 people could have $180,000 in tipping fees, and over a 15-year capacity at their landfill, that could be worth $2.7 million. Or alternatively, if you didn't have that asset, if you didn't manage it properly, you'd be looking at having to pay out that kind of money plus trucking or hauling to use somebody else's site. Next slide, please. So waste disposal sites are a little bit different than some of the other assets we've discussed this afternoon, as they have a fixed lifespan. ARO calculations are done. In order to do ARO calculations, it's imperative to understand where we're at in the site life. Waste capacity assessments are typically done to figure out, how much waste is in the site currently. For area fill landfills, so that's where you have something like I've shown here. You have a pile of waste that's above grade. Those are very simple to do. You would just do a survey, topographic survey, and figure out how much waste is there versus your theoretical capacity, and figure out what the difference would be. For trench and fill landfill sites where you're actually digging a hole and filling, you have to get a little bit more creative and do some intrusive work, dig some test pits, drill some boreholes, figure out where the garbage is, and what the depths are, etc. So then, based on your site-specific limitations and the regulations in your jurisdiction, the footprint, the volume, the waste height, the slopes, the setbacks, will dictate, what your theoretical capacity of the landfill could actually be. And the difference between your current volume and your theoretical volumes provides you insight into the remaining site life and a forecast of the complete closure date. Next slide, please. The remaining landfill volume can then be divided by your average annual waste deposition rate, as it equates to the number of years that are left in the site. This can be estimated from incoming waste counts. However, annual topographic surveys are typically the best measure of in-place volume, as they account for compactive efforts and that sort of thing. So with the advancements in drone survey technologies, it makes the annual topographic surveys quick and very accurate, as each pixel essentially equates to a survey shot. So you can get a really, really good estimate on a year-by-year basis of how much volume you've actually brought into your landfill site. And then you can use that average rate to figure out how many years you have left in your facility. Next slide, please. One thing that's important to consider, and it's a real opportunity to manage your site as an asset, is sequential or progressive closure of cells as they reach their final waste contours. If you manage your site in this way, as you fill a cell of your landfill, you could apply the final cover, and in that way you can remove the associated closure liability of the site as you're closing it. You don't have to close the entire site in order to write down your liabilities. Next slide, please. Once the site is closed, other things that you need to consider in your ARO is the post-closure monitoring responsibilities. Several jurisdictions have specified minimum post-closure monitoring periods. Other regulators require the calculation of site-specific contaminating lifespan. Once you define what your post-closure period is, and that can be a quite lengthy time period, you need to calculate the associated monitoring, maintenance, and post-closure / reporting costs. Next slide, please. So whether you do sequential closure or complete closure, the regulations in your area need to be complied with, and the ultimate end use and approvals have to be factored into your closure costs. One of the things you need to have a real good understanding is what is your closure area. Are there any supporting infrastructure that you need, like ditching, roads, fencing, that sort of thing. And that all has to be factored into your closure concept and closure costs. Next slide, please. So yeah, the closure costs must include regrading of the waste to comply with design contours, as well as the installation of the final cover and vegetation system. Typical cover system is comprised of a minimum of 2 feet of low permeability soil, like a clay, covered by 6 inches of topsoil. If clay is not readily available, there are engineered products that are equivalent to that clay that are usually installed between 2 1-foot layers as a minimum of sand, and then this is again covered by 6 inches of topsoil. As mentioned before, there are benefits to progressive and phased closure if the site operations allow you to shape and cover the waste as you move forward with operations. So what you can see here, we've presented is a sequential fill plan for a landfill site, so that as you develop through the sequences, you can, at your leisure, cover and close certain parts of the landfill site, so that when you get to the calculation stage, you have less of an area that you have to deal with for the earthworks for reshaping and cover systems. Next slide. So yeah, this kind of just speaks to the two different cover systems that are typically used for waste disposal sites. As you can see, they're fairly similar. There's a organic layer on top that allows there to be vegetative growth. Beneath that, there's a system, whether it's low permeability soil or a geosynthetic clay liner, that reduces the amount of water that can infiltrate through the cap, thus generating landfill leachate. So this is standard in almost all provinces and all states. Next slide, please. So yeah, your post-closure care needs to include several factors, as I've touched on a couple times. You have to have an idea of what it's going to cost you for your final cover and vegetation cap inspection and maintenance. Even once you have your cap down, there will be, rills and gullies, animal burrowing. Sometimes you'll have vegetation, like trees will grow. Some provinces require that you actually manage the vegetation so that you don't get large trees that can grow and become uprooted, and the root mat tears the cap away. Yeah, then you'll have the associated infrastructure that goes along with the site that you have to continue to maintain so that you have access to the site, such as roads and fencing, your water quality monitoring facilities, that you're monitoring wells, flumes, or any other kind of systems that you would have in place. And then other things to consider is your monitoring reporting program. How many wells do you have? How frequent do you have to test them? What are you testing for? What is your reporting frequency? All those things have to be factored in. And then lastly, there's usually a line item for contingency. That allows for, potential future impacts. If you were, if you had undesirable groundwater or surface water impacts, how do you mitigate those? So there's usually an allowance that's carried for that. In Ontario, the standard formula is 50 cents per every cubic meter of waste that's in place. And that's multiplied by an inflation adjustment similar to what Dale described, that takes into consideration the non-residential construction index in the area. Next slide, please. Yeah, so we typically factorize the costs associated with the closure of a site, and it's not always once you calculate what it costs you to do this, it's not always fair to say, okay, well, we have a 4-hectare landfill site and we know we have to put a clay cap on 4 hectares. If you've only utilized 1 hectare of the facility, you don't have to carry the cost to do the whole thing. It's always good to know what that number is going to be, but if you've only utilized a percentage of it, that's what you need to carry, just in case you had to, do an emergency closure as of today. So yeah, so for closed sites where you're already filled and you're already at your capacity, or it's as big as it's going to get, that capacity factor is 1. But for the rest of the sites, usually what we do is we figure out what your permitted volume is and how much do you have in there today, and we apply that factor to your site. And I'll show you an example of that when we look at the cost sheets. Next slide, please. So yeah, these are our cost sheets for the examples for the closure costs. So you can see here, there's a line item for regrading of the waste. There's a line item for applying, the landfill cap and the vegetative cover. Those are your big ticket items. You have some other costs. This particular one here was we carry miscellaneous costs associated with pickup of litter, because they had a lot of wind-blown litter on this site. It wasn't really maintained very well. Other things that we considered are, monitoring wells, both in the source area as well as in the down gradient area for compliance. You can see those numbers are zeroed out here because we actually installed those wells as part of the operational phase. So again, if you can do some of this work that's required as part of your closure plan and your closure requirements, if you do that up front in your operational stage, you get to take that off your liability estimates. Next slide, please. So this is your post-closure care estimates. So again, it's what does it cost you to go out and do inspections of the cover every year? Again, depending on what your license is for the landfill, sometimes you have to do that twice a year or once a year. So we've applied those costs. Similarly, we have inspections of the other infrastructure on site, fencing, roads, etc. We know what the costs of the annual monitoring reporting for this site are. We've applied that. We also have the window of what is your post-closure window. On this particular site, it's a 25-year period, so we've factored that in. And then at the bottom of the page here, you can see we talk about, what is the capacity of the site, what's the remaining capacity, and you can see how we've factored out. At this particular site, we're only at 60% capacity, so we're able to use the 60% of the total estimated expenditure, and that's how we generate those numbers. And I think that's it for me, Aaron.
Great. Thank you for those excellent presentations, all four of you. That was really informative. Question, and it's kind of related to Tim, Dale, and Sean. Given that there's so much data, this is such data sensitive compilations that you're doing. All the people on the call will be gathering data every year, whether it's HAZ surveys or evaluations of their in-ground infrastructure or landfills. Maybe one of you could comment, what would be the best way to gather data that's useful for us and useful for the accountants to generate these as part of their ongoing maintenance process? Maybe, Sean, you want to start that one?
Sure, I can try and elaborate on that. Yeah, so to sort of correlate your data, or to, if you, a lot of the clients that come to us have pre-existing data already. And that can be in the form of assessment reports for asbestos, or assessment reports for hazardous materials, because I think I mentioned earlier that under most provincial regulations, there's a requirement to have a asbestos or hazardous material assessment on file of all buildings, regardless of, if you're going to dispose of it or not. And this is regulated under provincial law and regulations, whether it's in British Columbia, Ontario, or Alberta, or any province. So many of our clients, when they come to us, they do have reports on file. Now, the caveat is that those reports may not be suitable enough for ARO, but they certainly give us a starting point to be able to look at it, do a gap analysis of those reports, and then see what needs to be filled in. And in some cases, those reports actually might be quite detailed, and we can base the cost off that. In other cases, the reports are maybe out of date. It's lacking detail, it's lacking quantities, which makes some gaps that need to be filled in. But as a starting point, I think that would be the best way, is to assemble all the reports you might have on file.
what I was getting to, Sean, is you probably want quantities, hey? You want as much as possible the surveys that are done to have unit quantities of what the materials.
Yeah, that's correct. And many of those reports, they might have quantities, but some don't. So if they don't, then it makes it more challenging for us. And that's where something you would document into your methodology is that if you are trying to develop costs and the quantities are maybe assumed from a desktop exercise, then that becomes certainly an item that needs to be explained very well in the methodology.
Thank you. Okay. Dale, anything to add to that?
Well, I would say for site features, quite often the source of information is going to be someone that has, you know, fairly intimate knowledge of the site and the operation there. You know, certainly looking at the asset list and determining what may be on municipal service, what isn't on municipal service is going to be a good indication as to when you're going to have, you know, potential heating oil or, you know, drinking water wells, sewage systems, things of that nature. But a lot of the permits and, you know, well records, these things can be sourced, but they're not generally, you know, at your fingertips when it comes to looking for this information. So talking to someone from facility management or an operations standpoint and understanding what infrastructure is there at the site, then you can dig deeper and see what's available for doing a desktop review at that time. But yeah, going to someone familiar with the site and collecting that information is imperative.
Thank you. Tim, anything to add to that?
Yeah, for me, it's just volume estimates. You know, what do you have in your site now, and your license? What are you allowed to have? So those are the two big drivers for us.
And the more data you have, the more accurate our estimates can be, and the more complete our report is, and therefore the more valuable it is as an accounting exercise, I would imagine.
Yeah.
Good. Okay. All right. Well, with that, then I will thank our 4 presenters for their great presentations today. Thank you to Erin and Charlene in the background who helped with the setup and the slide moving and all the organization that makes this go so well. And thank you to all of you, our participants, for continuing to be part of our story, bringing these innovation webinars to all of you so we all learn together to navigate the regulatory and logistical hurdles of reporting and everything else we have to do when we manage our assets. There will be a survey sent out or come up on the screen as we close. I encourage you to fill that out because from your survey feedback, we can provide more and more of these kind of relevant webinars to you and help you learn and help us learn and help us all grow together. So thank you very much, everybody, for being on the call. Have a great day, and we'll see you next time.